Thank you. I just have 2 points that I wanted to make. The first one is based on one of the questions that one of the guests asked when the first speaker spoke. He asked if it is possible for us to be able to identify where a teacher comes from in terms of university. And I wanted to talk about that question. The first speaker spoke about sustainable frameworks. And I think once sustainable frameworks are being implemented, that is where now we would be able to have teachers being able to teach the same way. I don't think that teachers should teach differently, because at the end of the day, we have a common goal, and that is to ensure that teaching and learning happens effectively. So I think that universities need to have their own framework as to how they want to teach educational courses, so that all educators in terms of STEM-related subjects come out having the same knowledge, the same approach when they teach different subjects. And then the second point is about transition from basic education to higher education, which is basically academic readiness. In terms of academic readiness, I wanted to highlight something that maybe one of the officials from the Department of Education can be able to take note of. When learners enter into the education system, they are profiled. So a learner has a profile from grade 1 until grade 12. But the problem is that that profile is not being provided from middle school going to high school. Some learners enter high school, come and do science and mathematics subjects without their profiles being provided to high schools. So they enter high school with barriers to learning that have not been clarified to high schools that are being admitting those learners. So you'll find the learner entering into a high school to do maths and science who cannot read, because now their profile was not provided to school. And the same thing happens when a learner leaves grade 12 going into university. The university does not receive the profile for these learners. Therefore, universities basically admit learners on a blindfold. They are not aware of the barriers that learners have entering into university. So I think effective communication between university and our basic education needs to be established, so that the universities are able to obtain learner profiles for each learner that they admit from grade 1 until grade 12, so that they're able to identify any barriers, any shortfalls in terms of their academics, or any concession needs, because some learners enter into university with concession needs. Some of them write slow, some of them are slow readers, but such things are not being highlighted to universities. So I think profiles need to be available to high schools, and they also need to be available to universities. That way, when the learner is admitted into STEM courses and STEM subjects at a high school, we are already knowing that, okay, this learner will be able to pass these certain subjects and will be able to cope with the syllabus as it goes on. So that's what I wanted to highlight. And also universities could maybe start having more research about the high schools in which they admit learners from, so that they are able to identify which schools have a laboratory and which schools do not have a laboratory, so that when learners are admitted into their high schools, they can be transitioned into programs that can be able to assist them to be able to curb their barriers and to assist them to be able to perform better in STEM-related courses. Yeah, that's what I wanted to say about everything. I thank you.
Thank you. That makes a lot of sense. Thank you very much, Kelly.
Thank you. You're welcome.
Hinsa Mhlani. Yes, please go ahead.
Thank you. Yeah. The issue of language in science and maths again came up, and I must admit that I've never understood it, because it was a big thing in the 90s, and I remember institutions like the University of Durban Westville had a lot of research. And I know, PhDs and professors today who are a product of that era, but it was never explained. And I was happy to see Professor Shan, whom we invited while I was at the Center for the Advancement of Science and Education way back in 1994. And she was invited because she came from a country like India. She had worked there, although she studied in the UK. And the thinking by people like John Volming at the time was that she was going to be very, useful in helping us solve that problem. But I was a bit depressed that the same questions that were being asked way back then are still, persistent. And I'm just thinking that whoever in the audience has got good understanding of what this problem of language is can tell us, and maybe we are barking at the wrong tree.
Right.
Thank you.
Thank you very much, Insa. That's very important. Yes.
Can I respond?
Yes, yes, please.
Yes, thank you for your question about language. It's a very challenging aspect when we look at our history of colonization. And it's one of my areas of interest in research. And I want to take from, now I can't remember a name, who presented on Maths, the third speaker. It was the end of the presentation. She made reference to say Maths is its own language. And that it is important that learners be exposed to that language. I agree with her. Now, when we look at our history of colonization, because of colonization, our own languages did not continue to develop. For us, our indigenous language did not develop to enable us to have, for example, our own textbooks in STEM subjects. We have so many terms that where we don't have indigenous equivalents, where we can write our own textbook. So my argument at the moment is we can't really, for example, it will be very challenging to produce a biology textbook in our various indigenous languages. But what is important for me at the moment in terms of language is when we teach, we need to contextualize, which is linked to the decolonization aspect. For example, I don't have a term for a gene. I don't have a term for DNA. But what is important then when we are teaching is to draw examples and images from our own context to help our students then to understand the language of science, the language of maths, the language of physics. That is my response. Thank you.
Fantastic, Prof. Eunice. I hope that that you are working on that and that we'll be able to see technical dictionaries coming out in various languages.
Yes, so now we are working on the process now of having the science, the maths in our own language. But it's a work in progress because it was affected by colonization, the development of our languages.
Absolutely, and by apartheid. So it's a huge job, and I'm really hoping that there will be progress in that regard.
Yeah, I hope so too.
Richard?
Thank you. I just wanted to make a comment that because the stimulator is on a cloud platform, the cost of publishing is very small. So we actually have already planned to have buttons on the stimulator that will allow you to choose your particular language. So the visual content is pretty generic and will stay, but generally the pages of text will be able to be provided in the language of your choice by the selection of a menu system. So when you register for the stimulator, you will be asked what is your country of origin or country of interest. And then from there, we're already talking to a crowd in Kenya who've expressed an interest in it. So that conversation has started. There's no reason why in South Africa we can't cater for some of the official languages that we have internally. So again, it will need a sponsor. We can't just say we're going to do it because we can't do it. But the mechanism is there. And rather than printing 9 versions of one textbook, we can actually just change the text on the pages within the stimulator on a very simplistic digital platform. So if you can help us with that project, we'd be very excited to bring you on board, because that's a very easy variation to make to the stimulator.
Fantastic. Thank you, Richard. Patisizwe?
Thanks, Yancy, and thank you for the nice presentations. The issue about maths and language got me thinking. The CAPS document defines mathematics as a language that uses symbols. And to share one story, at some time I had to do a demonstration lesson with grade 4 learners, standard 4 those days, not grade 4. And the topic I had to teach them was how to use multiplication to do division. So because I want them to use multiplication, I wanted to check if they know multiplication first. And when I got into the class, the first question I asked them was 3 multiplied by 4. They just all looked at me. When I went to the board and wrote 3, a multiplication sign, and a 4, all the hands went up. Because that cross, that X, is not attached to any language. You could say it in any language.
Yeah.
If you see a cross, you know that this means I must add. If you see the symbol of 5, the other one sees faith, the other one sees kushan. You know, that symbol it draws to many languages. So I think that's also powerful for us to use the right notation, because I believe that no language has all the right concepts for the language that's needed in mathematics. Thank you.
Thank you very much, Patisizwe. That's a very interesting point. Hintsa, do you have another comment or question?
Yeah, just I'm happy that Pat has responded to this, because that was my confusion. Are we talking technical language, or are we talking a language like English? You know, there was a lot of talk that because African children who come from the townships and the rural areas are not proficient in English, they were struggling in subjects like mathematics and science. And as a person who was a teacher, I'm not too sure that that is true. And all the research that was done in those days went into that. Professor Shan spoke about multicultural classrooms. And even today, what was defined by that concept. So, yeah, I'm really getting depressed that we seem to be recycling the same things all over again and not moving forward. And we are avoiding, the very uncomfortable questions that we should be asking ourselves as the education community. I was hoping that, I could pick up that there were a lot of experts who were here. They were going to help us maybe understand some of these things for some of us who are, I must say I'm at sea when people speak about certain things, and as a person, I become very depressed. I don't pretend that I understand something that it was just that what is the language that we're talking about? Those who of us who are my age will remember that South Africa did have indigenous, it did have textbooks of science, history, and arithmetic in indigenous language. When I was in primary school, I learned environmental science in the vernacular in isiZulu. So maybe we could go back there, just because that was associated with. I mean, look at Afrikaans. How the National Party government was able to elevate Afrikaans to a level of an international language. And you've got, I mean, you can study in Afrikaans universities now, and you can do research in Afrikaans. You can. Why is it not happening with why are people who are academics in the other languages not pushing for that? That's instead of us decrying the fact that over and above learning the content, then we should be also linguists. I'm not too sure whether that really helps, you know. Thank you.
Thank you, Hinsa. Would any of the speakers like to respond to that? I mean, at the moment, the policy is that children will be taught in their mother tongue up to grade 3. And that is confirmed in the Bella Act. So those resources must be continue to be made available, and those teachers must be taught to teach the concepts in their mother tongue. But the problem for me is that the technical language has still not been translated into the 11 languages or 12. So that there's a huge problem at the top. It's no good for teachers to be teaching at a lower level, and they have to be inventive about the language they use to explain, or they have to use their textbooks. And then there isn't a carry through right the way to grade 12 and beyond. Anyway, that's what I think. Yes, Krista Jones. Krista, just unmute yourself. Yes.
Thank you so much. Thank you so much. I think the later speakers, I don't know if you can hear me, but thank you so much. We are doing efforts indeed, and to translate, not translate, to version, which means a word might have this how you pronounce it in this language, but in another language there's no direct translation for the word, and it might be explained, which means it's a number of words that will explain the very same different term. So really we are really poor in the indigenous languages in terms of finding words for especially the technical terms and the new language we're talking about in terms of coding robotics. For example, when we talk about sensors, LEDs, and all of those motors and all of this. So it's quite challenges, but I think we are moving in the correct direction by creating versions of it, not really translation, but versioning of it. So in the near future, we'd love to say, no, we have addressed all of this, and we encourage teachers to say, if you can teach this concept in your language that the learner also understands, better be it for the learner as well. So thanks for bringing up that concept. We, as a DPE, as Department of Basic Education, we are attempting to version, especially grade R up to 3, all the subjects.
Good. Fantastic. Thank you, Christo.
Thank you, ma'am.
But Sizwe, is that an old hand, or do you want to talk again?
Oh, I'm sorry, it's an old hand.
Okay. Christo Jones, I would just like to ask whether the curriculum for robotics and coding is available on the web. No?
Yes, indeed, it is available on the web. It's on the web on the DBE portal. But I don't know if I can get the link to post to you. But it
Okay,
is there.
great. That would be great.
Thanks.
Otherwise, we can include it in the communications that we send out afterwards.
100%. Thank you, ma'am.
Okay. I think it's wonderful that robotics and coding are included now in and that the digital concepts have been developed, because comment that we heard last year was that coding and robotics are not really supported by the theoretical components. So that is very welcome news that that is now part of what the learners will be learning. Okay, I think with that, we must close this discussion. Thank you very much to all our speakers who have, most of whom have stayed on and engaged and listened to the other presentations. Thank you very much to all our participants, still 44 of them who are listening, so they have definitely heard what has been shared last minute. And thank you to my staff and colleagues. I hope you have a good rest of the day, and do check the NSTFE news for a report on this discussion forum, and have a look at the website where all the presentations will be shared. Okay, keep well.